Right, okay, so what we're going to cover in this presentation is a brief overview of what we mean by cross-elasticity of demand. The definition of all these different elasticities are all very, very similar. Again, you would start off with the word responsiveness. But for this elasticity, it's the responsiveness of demand for one product, so product A for example, to a change in price of product B. So in other words, how much demand changes for one product as the price of another product changes. The equation for this one would be percent change in demand for A divided by percent change in price of product B. Okay, now from this equation what we will generate are either positive or negative numbers. If we get a positive number, so let's take an example, let's imagine that the price of Pepsi increased. We would expect the demand for Coke to increase. As these two products are substitutes, positive numbers shows us substitutes. Negative numbers therefore show us the complementary products. Now let me just draw a diagram to explain the relevance of this. We'll use one to show substitutes and one to show complements. The examples I always use to remember this, for substitutes, think Coke and Pepsi. Complements, think about a PS3, so a games console, and the games. So in other words, products that we tend to use together. Let's imagine I'm now drawing the market for Coke. So I've got the supply of Coke, and I've got the demand for Coke, and I've got an equilibrium point. What I want to know now is what will happen to the demand for Coke as the price of Pepsi increased. Okay, so what we would expect, because Coke and Pepsi are substitutes, as Pepsi becomes more expensive, more people will buy Coke, which would shift the demand curve for Coke to the right. Clearly this will lead to higher quantity for Coke and an increase in the price of Coke. Obviously the reverse is true, so for example if Pepsi prices fell, the demand for Coke would increase. How much demand shifts depends on how strongly related these products are. For some people, as the price of Pepsi increases, demand for Coke might not shift at all, so it might stick at D. That is because they don't like Coke, they prefer Pepsi to Coke. Other examples of substitutes could be travelling by bus versus travelling by car. For me, my car offers great convenience over the bus, so even if bus fares were to fall to practically zero, my demand for buses wouldn't increase because I would personally prefer to use my car. Likewise, if petrol prices doubled, my demand for bus travel would remain the same because I view them as weak substitutes. For me, Coke and Pepsi will be strong substitutes. So if Pepsi increased their price, my demand for Coke would shoot up. Let's move on to complements then. So imagine we're looking at the market for PS3 consoles. So again, we've got supply and we've got demand. Now in this case, a PS3 and a game, so the games that go with the PS3, have to be strong substitutes, I beg your pardon, strong complements, simply because they have to be used together. One on their own is no good without the other. A games console without a game, well, what would you do with it? A game without the console again, how would you work the game? So what I want to know now is what would happen to the demand for the PS3 as the price of games change. So we've got the equilibrium point at P1, Q1. If PS3 games were to improve in quality or to reduce in price, we'd expect demand for consoles to increase. More people want the games, therefore more people buy the console. Obviously the reverse of this is true as well. If we were back at P1Q1, if the price of the games increased, demand would fall for this product. So what you have to remember from this is that if you're using the equation, a positive number will show you a substitute, and a negative number will show you a complement product. Now, one thing I would also say is remember that for a substitute, the bigger the number is, the stronger the two products are as substitutes. For complements, the lower the number is, so normally lower than -1 to -infinity, shows that they will be stronger complements than the number, say, of -0.3. Okay, if you remember those basic facts, then you've more or less mastered this topic.